Unit 2 addresses the concept of quadratic functions. Quadratic functions are brand new to you in analytic geometry, so let's start with some basics that you should have learned. Now remember, these videos are just reviews, so these are things that you should look familiar to you. Quadratic functions are functions that have a degree of 2. This means that the highest power on an x term is 2. So I don't see a power of 3. I don't see a power of 1 as my highest power. My highest powered term has a 2 as its power. When you graph a quadratic function, it's always going to create a parabola. A parabola is a U-shaped graph. Quadratic functions have a vertex. A vertex refers to the highest point or the lowest point. If you think about the shape of a U, this makes sense. If I were to draw a U on my paper, if it's pointing up, it's clear that I have a vertex. It would be my lowest point on my graph. If I had an upside down U, I have a vertex that would be my highest point. And lastly, when you see a quadratic function in function form, we need it to be in one of 3 forms. It needs to be in either vertex form, which is going to give me the vertex of the function immediately when I look at it. I don't have anything to think about. I should look at the function and immediately know my vertex if it's written in vertex form. Vertex form is always going to look like a set of parentheses raised to the second power and then have a portion added or subtracted from the end of it. Factored form is going to automatically give me the x-intercepts of my function, and it will look like 2 sets of parentheses instead of 1 set raised to the second power. And standard form is always going to give me the y-intercept of my function, and it looks like no sets of parentheses. The parentheses have been multiplied out and like terms have been added together to create standard form. It doesn't matter which form I begin with. It doesn't matter which form I have. It's really a matter of preference as to which you prefer. You can start and create a graph of a quadratic function from any one of these forms. And we're going to look at each form individually. Next, we'll first start by looking at vertex form. Now remember, vertex form is going to give me the vertex of my function. So when I'm going to graph that function, that's going to be my starting point. Let's look at this first function. It asked me to graph the function f of x equals 2 times x minus 4 squared plus 3. When I'm looking at that function and I see a set of parentheses raised to the second power, that's a dead giveaway that this function is in vertex form. So I should be able to immediately look at it and know my vertex. And that's the point where I'm going to start. So if I'm going to graph this, I'm going to create a t-chart. And in my t-chart, the first thing I'm going to put is my vertex. My vertex is h, comma k. If we remember that vertex form we just looked at, h was the number that was in my parentheses. K was the number that was outside my parentheses. Now think about that vertex form. It said x minus h squared. So for me to know the exact value of h, I have to set that in my head equal to 0, what's there. So in my head, I'd be wanting to say x minus 4 equals 0. When I solve that, I would get the x coordinate of my quadratic function is positive 4. Now think about this. We talked about that the vertex is the highest or the lowest point. I need to interpret that as the middle of my graph when I create it. I know it's going to create this U-shape, this parabola. So I'm going to put that vertex into the middle of my t-chart. So my vertex will be positive 4, positive 3. Now from there, I want to get some points that are around my vertex. I want some points that are to the left of my vertex, and I want some points that are to the right of my vertex. So if I'll always make my x column go in numerical order, I can figure out the other points by plugging in these values for x. When we're graphing a function, we interpret the x as our input, the y as our output. So we can put in what number that we like and get out that value for x, for y. X is my independent variable. Y is my dependent variable. Y is dependent upon what X is. I do not know Y until I know X. So if I plug in 2 to my function, I'd say 2 times 2 minus 4 squared plus 3. I'm going to follow my order of operations, work out what's in parentheses first. So that would give me negative 2, because 2 minus 4 is negative 2. Negative 2 squared is 4. So that gives me 2 times 4. Two times 4 is 8, and 8 plus 3 is 11. So I have the point 2 comma 11 is also on my graph. Now, the thing with a parabola is there's always the symmetry. You think about the U shape that results. That parabolic shape is symmetric around the vertex. So I noticed that that value I just plugged in is 2 to the left of my vertex. So I can expect the point that's 2 to the right of my vertex to have the exact same Y value because that symmetry will be created. And I can very quickly plug in 6 for X. 6 minus 4 would give me 2. 2 squared is 2. 2 squared is 4, I'm sorry. So I'm coming out with the exact same expression I had here. 2 times 4 plus 3, which gives me 11. That power of 2 is going to always create the same value here when I raise negative 2 to the second power as when I raise positive 2. So the symmetry happens automatically. When I plug in 3, I'd say 2 times 3 minus 4 plus 3. I'm going to do this a little bit faster here. 3 minus 4 is negative 1. So I'd have 2 times negative 1 squared plus 3. Negative 1 squared is 1. So I'd have 2 times 1 plus 3, which gives me 2 plus 3, which is 5. Now, that point that, so I'd have the point 3 comma 5. 3 is 1 away from my vertex. It's 1 to the left of my vertex. So 1 to the right of my vertex will result in the same Y value, which I could figure by plugging in 5 if I wanted to. But now let's plot these points. I'm going to plot the point 2, 1, 3, 5, 4, 3, 5, 5, 6, 11. Now what should happen is I see a U shape. Oh, I plotted the wrong point right there, didn't I? Let's do that one again. That was supposed to be the point 2 comma 11. Sorry. But I could tell that my graph was incorrect because it didn't create a U shape. I don't think I plotted 6, 11 either, did I? Here we go again. Didn't press enter. Okay, so I see those 5 points that I just plotted. It's going to create a nice U shape for me. Let's draw in that graph. And there is my parabolic shape, my U-shaped function that resulted from a T-chart that resulted from that equation. Okay, now that's 3 different representations of the same quadratic function. This is my equation representation. This portion right here is my T-chart representation. And this is my graph representation, all of which represent the exact same quadratic function. Let's look at another example. Let's get our vertex immediately. I can tell that the parentheses raised to the second power is a dead giveaway that I should be able to look at this and know my vertex. So if I create me a T-chart, let's put that vertex into the middle of my T-chart. The reason I'm doing that is because that is exactly where that vertex is going to be on my graph. My vertex will be positive 5, negative 2. I'm always flipping that sign that's in my parentheses. I need points that are around my vertex. So to the left of 5 would be 4. Remember, these are x coordinates. To the left of 4 would be 3. To the right of 5 would be 6. And to the right of 6 would be 7. Let's just plug it in our head this time. Let's start with 6. 6 minus 5 gives me 1. 1 raised to the second power is 1. And negative 2 times 1 minus 2 would give me negative 4. That was when we plugged in 6. I'm going to use symmetry to my advantage here. Save me a little bit of work. 6 is 1 to the right of my vertex, so I expect the point that is 1 to the left of my vertex to have the same y coordinate. So I can go ahead and put negative 4 around 4. Let's plug in 7. If I plug in 7 for x, that would be 7 minus 5, which is 2. 2 squared is 4. So I'd have negative 2 times 4 minus 2. Negative 2 times 4 is negative 8. Negative 8 minus 2 is negative 10. So I can expect that for my y coordinate to attach to 7. Now let's plot our points. 3, negative 10. 4, negative 4. 5, negative 2. 6, negative 4. 7, negative 10. And then we show our parabola. And it connected quite nicely. I see that U-shaped function. Now, I will compare this one to my last one. My last parabola pointed up. This parabola points down. Is there anything in this function that you would compare to this function that would make you think that parabola points up instead of down? This parabola, if we notice that a value that's in the very front being multiplied by my parentheses is positive, and in this example, that a value is negative. So that a value is going to cause my parabola to open up or open down. We'll look at some more examples on the next video.